Welcome to this video. I'll be solving yet another AP Calc AB exam, the multiple choice portion. And as always, I'll start with my disclaimer that I'll leave it up to you to figure out whether the content covered in this exam is relevant or not to the AP Calc AB course as of whenever you're watching this video. I'm assuming you're taking AP Calc AB, okay? There might be some topics that aren't covered anymore, or maybe they got moved to BC, or maybe some topics that aren't covered here are actually tested now. So I'll leave that all up to you, okay? And then one specific example is, for example, L'Hopital's rule. I don't know if that's covered in AP Calc AB anymore, but I might be using it to solve some of the problems here, okay? I'll try to solve them without L'Hopital's rule if doable, but yeah. So there's that disclaimer, and then I feel like there's another usual disclaimer. Maybe it's just that one. And I'll probably solve like maybe a third or half of the problems, and I'll continue in another video, okay, or another few videos or so, okay? So let's begin. We have the integral from 1 to 2, x to the minus 3 power dx. How do we solve this? Well, we just use the power rule. So what would that be? Let me set up my pencil. Okay, so that would be what? We add 1 to the power, so it'll be it's x to the minus 2 over minus 2. Evaluate from 1 to 2. Is that visible on camera? Okay. So that is what? That would be 2 to the negative 2, or let's just write it like this, negative half, that's the constant, 2 to the minus 2 power, minus 1 to the minus 2 power. Fundamental theory in calculus. We plug in the upper bound, plug in the lower bound, okay? This is minus half times 2 to the negative 2 power, that's 1 over 2 squared, which is a fourth. This is just minus 1, so minus half times minus 3/4. So this is 3/8. 1 is D. Okay? If f of x is 2x plus 1 quantity to the fourth power, then the fourth derivative of f at x is equal to 0 is what? Okay? So, excuse me, let's start taking derivatives. Okay? We would need the chain rule here. Okay, so f prime would be, but we first do the power rule, it'll be 4 times 2x plus 1 to the third power times derivative inside, so that's times 2. Okay, second derivative, that would be 4 times 3 times 2x plus 1 squared times 2 times another 2 from the chain rule. Or this times 2 we can say is from this chain rule, and then there's another 2 up there, so 2 squared, okay? Third derivative would be 4 times 3, again we do the power rule, times 2x plus 1 to the first power, times the derivative of the inside, that's 2 again, so it'll become 2 cubed, okay? Fourth derivative would be what? 4 times 3 times 2 times derivative of this guy. These are all constants, right? So we can, and this is a constant, so we can treat those all as 1 and pull out in the front. But derivative of this guy would be 2. Okay? There's 2 cubes from that. Okay, so what do we get? We get 12 times, okay, so this is 12, 4 times 3, 2 times 2 is 4. This is times 8, okay? So that's 12 times 32, okay? So that is what? 320 plus 64, which is equal to 384, okay? That is choice E. Okay, so we just have to do chain rule a lot of times. If y is 3 divided by 4 plus x squared, dy dx is equal to what? Okay, so here we can rewrite y as, how should I do this? Let me just write it here. Y is 3 times 4 plus x squared to the negative 1 power. We can do this so that we can just do chain rule. Here, you could do quotient rule, but that's a little more tedious in my opinion. Okay, if this is y, then dy dx is equal to, first to the power rule, so it'll be minus 3 times 4 plus x squared to the minus 2 power times derivative of the inside, which is 2x. So that we can rewrite this as minus 6x over 4 plus x squared, quantity squared. Okay, so 3 is A. If dy dx is equal to cosine of 2x, y is equal to what? That's just, we find the antiderivative of cosine 2x, or the integral. So integral cosine 2x dx, that would be half sine of 2x plus c. And that is choice C. This one, limit as n goes to infinity, 4n squared over n squared plus 10,000n is. There's a long way to do this, there's a short way to do this. The short way to do this is we realize that it's a horizontal asymptote, it's a rational function. As n goes to infinity, it's the asymptote, okay? Horizontal asymptote. Degrees are the same, so we take the ratio of the leading coefficient, so that's 4 over 1, which is 4. That's the quick way. Okay? The long way to do this is, remember the technique? Whoops. We factor out the biggest degree from the top and factor out the biggest degree from the bottom. So it'll be n squared times 4 over n squared times, when we factor that out, that'll be 1 plus 10,000 over n. These can cancel. Now we take the limit as n goes to infinity. This guy would go to 0, so we're left with 4 over 1, which is 4. Same answer. Okay? There's a multiple choice, so if you do the degree test and get 4, that's obviously the quick way because you don't have to show any work. There's a multiple choice. Okay? F of x is x. F prime of 5 is equal to what? What's f prime of x? Is equal to 1. So f prime is 1 everywhere. 6 is C. Which of the following is equal to ln of 4? Okay. This one, what would this be? This would be ln of 3 times 1, which is ln 3. That's not the case. This one would be what? Can we simplify this? Because only if it's a difference, we can put it as a single log, but when it's a fraction of 2 logs, we can't make it as ln of 8 minus 2. That's not valid. So I don't think this is even simplifiable. Okay? How about this? Integral from 1 to 4, e to t dt. That's just e to t evaluate from 1 to 4, which is equal to e to the 4th minus e. That's not ln 4. This one, you need integration by parts to solve that. I don't know if you learned this in AB, so let's skip that for now. How about this one? This is just ln of t evaluate from 1 to 4, which is ln 4 minus ln 1. ln 1 is just 0, so it's ln 4. So this is the answer, okay? This one I knew it wasn't because I know BC calculus and I know integration by parts, so that's not the answer, I know that, but if you don't know that in AB, then you could have still gotten it from this one, okay? Excuse me. Slope of the line tangent to the graph of y is ln of x over 2. At x is 4 is what? Slope of the tangent line, that should signal derivative, okay? So y prime is, what's the derivative of ln? That's 1 over the argument. We need to chain rule times derivative of the inside, so that's half. Okay, so y prime is, we can write this as 2 over x times half, which is 1 over x. We evaluate at x is equal to 4, that is equal to 1/4. So 8 should be B, yes. Okay, if integral from negative 1 to 1, e to the minus x squared dx is equal to k, then integral from negative 1 to 0, e to the minus x squared dx is what? So here, the thing that you should notice is, oh, we have limit from negative some value to the same value but positive. -1 to 1 in this case. Maybe that should signal it's maybe an even or odd function, and we can do something about that. Okay, and notice that this is from -1 to 0. So this is half that interval. Okay, so with that said, is this an even function? Is that an odd function? Remember what even function is. If f of negative x is f of x, this is even, right? Even. So is it even over here? If we plug in negative x into x, we get negative x squared, which is x squared. That negative x doesn't affect this negative sign over here. So it's the same as an even function, okay? So it'll be the same thing. So because it's an even function, we know that this guy, let me call this guy I, okay? I is also equal to 2 the integral from -1 to 0 e to the minus x squared dx. Or you might recognize that as, remember, 2 integral from 0 to 1 e to the minus x squared dx. Okay? They're the same thing. Okay? Just one's from using the upper limits. This is using the lowers. Okay? So if this guy is equal to k, then half of it, I just said half, should be k over 2. So 19 should be, I'm sorry, not 19, 9 should be d. That's correct. It's an even function. If y is 10 to the x squared minus 1 power, then dy dx is equal to what? We just use chain rule here. How do we differentiate 10 to some exponents? That's not e. It's just, if you remember it, it's 10 to the x squared minus 1 times ln of the base, so ln 10. Okay? We need to differentiate the inside because it's chain rule, so times 2x. Okay? So, which answer is that? That looks like D. Okay? By the way, if you don't remember the formula, or you don't remember if it's multiply or divide by ln 10, the way that you can remember is, well, 10 to the x squared minus 1, so we can rewrite it as y is equal to e to the ln 10 to the x squared minus 1. Okay? And you can rewrite this as, so this would be e to the, remember you can pull the exponent out, x squared minus 1 ln 10. So when you do the chain rule on this is just a constant, so it's times ln 10 when you differentiate e, right? So that's a different way to remember it if you don't remember the direct formula, okay? Position of a particle moving along a straight line at any time t is given by this guy. What's the acceleration of the particle when t is equal to 4? Okay. So acceleration is the second derivative of position. So let's find the first derivative first, which is the velocity. So s prime of t, I can even write just s prime of t, that is what? 2t plus 4. That is just power rule. 2t plus 4. S double prime of t, that's the acceleration, a of t, we can even say, is equal to 2. Okay? So it's a constant acceleration everywhere. At all time, not everywhere, at any time. So 11 is B. If f of g of x is ln of x squared plus 4, f of x is ln of x squared, g of x is greater than 0 for all real x, then g of x is equal to what? Okay? So this is just about composite function. So how can we make this? So if f is x squared, ln of x squared, when we put g of x, so okay, let's just write it down. So composite function means whenever there's a x for f, we plug in g. So if f of x is equal to ln of x squared, f of g of x should be equal to ln of g of x quantity squared. like that. Okay, so then g of x quantity squared should be x squared plus 4. Okay, so then g of x would be, we just square both sides, square root of x squared plus 4. I believe 12 is c, yes. Okay, so as simple as that. Composite function. We know that f of g of x is, if they give us f is this, then f of g of x is ln of g of x squared. Okay, and they give us what that is, that's here, so then your inside of the log, g of x squared should be x squared plus 4. Okay, so that's how I did it here. Okay, moving on. X squared plus xy plus y cubed is 0. Then in terms of x and y, dy dx is equal to what? This is just implicit differentiation. So x squared plus xy plus y cubed is equal to 0. Okay, we differentiate, so it'll be 2x, the parallel. Here we need product rule. First d second plus second d first. First d second plus second d first derivative of x just 1 plus derivative of y cubed is 3y squared dy dx. Derivative of 0 is just 0. Let's solve for dy dx. We subtract this term and this term to the other side. So x dy dx plus 3y squared dy dx is equal to minus 2x minus y. We can factor a dy dx from both of these terms and then divide by x plus 3y squared. So let me just write it out for those who need to see it. Okay, so I factored. Now we solve for dy dx. Okay, that's how we do that. Which answer is that? Is 13A? Yes. Okay. Velocity of a particle moving on a line at time t is v is 3t to the half plus 5t to 3 halves meters per second. How many meters did a particle travel from t is 0 to t is 4? Okay. How do we do this? How many feet did a particle travel? We're given velocities, so we need to integrate the velocity. Okay, so it's the integral of v of t dt from 0 to 4. Okay, and by the way, velocity here is it, well, from t is 0 to t is 4. So between 0 and 4, this guy is always positive. Okay, so we don't have to worry about it moving in different directions, moving forward and then moving backward. Okay, just v of t dt is fine. Absolute value v of t dt is the more correct solution, but once again, this is always moving in one direction in this time interval, so we're okay there. Okay, so let me just write it. This is the proper way, but since it's moving in one direction, we can simply write it as integral from 0 to 4, 3t to the half plus 5t to 3 halves dt. Okay, so this is just power rule once again. It'll be 3 times 2 thirds t to the 3 halves plus 5 times 2 fifths t to the 5 halves. We evaluate this from 0 to 4. Okay, we can simplify to 2 times 4 to the 3 halves plus 2 times 4 to the 5 halves. When we plug in 0, we get 0 for both those terms. So we don't have a minus whatever, okay? By the formula of linear calculus, we don't have a minus the second terms, okay? So here we get what? 2 times 8 plus 2 times 2 to the 5th should be 32, if I'm doing it, if I remember it correctly. 2 to the 4th, yeah, should be right. Then this guy is 16 plus 64, which is 80. Okay, so then that is D. Domain of the function defined by f of x is ln of x squared minus 4 is a set of all real numbers x such that, well, what's the domain of log? The argument has to be greater than 0, right? So we need x squared minus 4 to be greater than 0. That'll be the domain. So x squared is, actually to solve inequalities, we can't do that, right? Let's see if it even has that. Okay, let's just do it my way that I'm thinking of. So if we factor, it'll be x plus 2, x minus 2 is greater than 0, okay? So let's find out where that is. We draw a line, okay? When we plug in a number much less than -2, a huge negative number, this would be negative, this would be negative, two negatives make a positive. You plug in some number in between -2 and 2, like 0, this would be positive, this would be negative, that sign would be negative. Plug in a huge positive number, positive, 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 okay? So, the domain is when this guy is satisfied, which is x is less than -2 and x is greater than 2. We don't include -2 and 2 because it'll be 0 at that point. We can't have ln of 0. That's undefined. That's be negative infinity, okay? So this is our solution. Now let's get it in a matching form. I just said that I cannot equal to 2, so we can already, it's definitely not all real, so we can eliminate those already. So which one is it? Okay, it would be this one. Okay, because if you remember, this means x is greater than 2 and x is less than -2, which is what we have over there, okay? Function defined by f of x is x cubed minus 3x squared. For all real numbers, x has a relative max at x is equal to what? Okay, relative max, that should signal, let's probably take the first derivative, okay? And do the first derivative test. Let me try to squeeze it in the sheet of paper. Okay, so f prime of x would be, what's the power rule? That'll be 3x squared minus 6x. We set it equal to 0 to find our critical points. So we factor a 3x from both terms. That would be x minus 2. Okay? So our critical points are x is 0 and 2. Let's do the first derivative test. You plug in some number much less than 0, a huge negative number. This would be negative, this would be negative, two negatives make a positive. Plug in a number between 0 and 2 like 1, this would be positive, this would be negative, the sign is negative. Plug in a huge positive number, this is positive, this is positive, this is positive, okay? So we have a relative max at this one because the derivative changed from positive to negative. In other words, f increased and then decreased. I don't know if I said this before if you've seen my videos where I said the saying that I remember is, when the function increases, the derivative is positive. When the function decreases, the derivative is negative. So derivative is positive, function's increasing. Derivative is negative, function's decreasing. So that means max. Here is a relative min. Okay, so it's at x is equal to 0, 16 is B. Okay. Oh, this is integration by parts. So I guess they expected you to know it in this year. So in that earlier problem, that was integration by parts. I forget already what it was. But anyway, how do we do this? We can do it the quick way via the tabular method, or we can do it the long way. The typical way, I'll just do it the typical way. Okay. So if we let u be, you should know that this is one of the classic, you could watch my crash course video actually. We have to let u be x because we want to reduce the power. Du would be dx. dv would be e to the negative x. dx, sorry. V is equal to negative e to the negative x, okay? So uv minus v du, that's this integral. So the integral, let's call it I, is uv, so it'll be minus x, e to minus x, we evaluate from 0 to 1, minus v du. So it'll actually be plus integral from 0 to 1, e to the minus x dx. So this is minus x e to the minus x. Okay, I'll evaluate it all at the end together. This one will be minus e to the minus x. We evaluate the whole thing from 0 to 1. That would get us what? Minus e to the negative 1 minus e to the negative 1 minus 0 minus 1, which is 1 minus 2e to the negative 1. So 17c, yes. Okay, that's how we do that one. Y is cosine squared minus sine squared, then y prime is equal to what? There is an identity, trig identity for this. I believe this is cosine of 2x. Okay. So then that'll be C. Let me check if that's the answer. It is. Oh, okay. So let me show you that quick way first. Then we can do it the long way. So I happen to remember that cosine squared x minus sine squared x is cosine of 2x. Okay, so if we differentiate cosine of 2x, that's just minus 2 sine of 2x. Derivative of cosine is negative sine. But then we have to do chain rule, so times derivative of 2x, which is 2. Okay, so the answer is C. That's the quick way. We can also just do it, if we don't know that, we could just use the chain rule from here, okay? Probably. Let's try it out. Let me just do it on a new piece of paper, scratch paper. Okay, so, or actually, can I fit it here? So it'll be 2 cosine x times minus sine x. We need to chain rule because we first do the power rule, so it'll be 2 cosine x to the first power times the derivative of cosine, which is minus sine. Okay, and then minus, here again, power rule first, 2 sine x times cosine x. Okay? Did I do this right? Yeah, this is minus 4 sine x cosine x. Okay? And there's, okay, so you still have to use a trig identity because I know that sine of 2, let's say theta, is 2 sine theta cosine theta. So this would become, if we want minus 4, we just multiply by negative 2 on both sides. So it'll be negative 2 sine 2x. So I guess you still have to do a trig identity. If you know this one, that would have worked. If you know the other one that I used, this one is equal to cosine 2x, that's probably easier. Okay. Next, f of x1 plus f of x2 is equal to f of x1 plus x2 for all real numbers x1 and x2, which the following could define f. Okay, so let's just start trying points, I guess. I don't know, a quick way to solve this. Because let's start to look at each choice and then eyeball it, okay? So f of x1 plus x2 would be, for this one, would be what? Would be x1 plus x2 plus 1. Okay, is that the same thing as x1 plus 1 plus x2 plus 2 plus 1? No, because that'll be a plus 2, so... Okay, so let me write it properly. This is f of x1 plus x2. F of x1 would be x1 plus 1. F of x2 would be x2 plus 1 for this one, okay? So obviously, if you just add these two up together, it doesn't equal to that, okay? How about B? So f of x1 would be 2x1. F of x2 would be 2x2. F of x1 plus x2 would be 2 times x1 plus x2. Distribute, that'll be 2x1 plus 2x2. Okay, which is the same thing as adding those up. So I believe 19 is B. Yes, it is. Okay. For the sake of time, I won't go over the next few. You can just even eyeball it, and you know, there's a fraction. You can't just blindly add fractions. You can't blindly add the denominators together. You can add numerators with the same denominator together. That's fine, but you can't add different denominators simply together. E, you can't do that for sure. X, this, you have to FOIL it out. That's not the same for sure, okay? Yes, if you had time, I would just double check each one, but for the sake of time in my video, and also when you're taking the test, if this was the test, I would just move on to the next one, okay? So I'm pretty confident about this answer without going through all the choices. And I have the answer key for the purposes of this video, so. Okay, if y is arctan of cosine x, then dy dx is equal to what? Here is just chain rule once again, okay? Outside in, what's the derivative of arctan? That's 1 over 1 plus the argument, so that'll be cosine squared, times derivative of the inside. What's the derivative of cosine? That'll be minus sine. Okay, so this would be 1 plus cosine squared. Can we simplify that? No, we can't. 1 minus cosine squared, we could. So is this actually one of the answers? Let's see. Yes, 20 is A. Yes, good. Domain of the function f is given by absolute value x is greater than 1. What is the range of f? Okay, so in other words, x, absolute value x is greater than 1. So in other words, x has to be greater than 1 or x has to be less than negative 1. Okay, this is same notation, okay? Now, as when x is greater than 1, let's do that one first, then this guy, when x gets bigger, well, this is x squared, so it'll be the same on the negative, because negative squared makes it positive, okay? So let's just focus on this one. When x gets bigger, something squared, x squared would get bigger, so this would tend to, this would, as x goes to infinity, that's just the proper calculus way to do it, right? As x goes to infinity, f goes to 0. Okay, so let me write that down. As x goes to infinity, f goes to 0. Okay? Now, how about as x approaches 1? What happens? As x approaches 1, okay, what happens? This would be, let's set it equal to 1. If it's 1, then it'll be 1 minus 1, which is 0. So it'll go to infinity, okay? So when we approach 1, it would be, what is it, positive or negative infinity? It would be 1 minus, so whether we approach it, no matter what size, it's squared, right? It'll be positive infinity. But 1 minus positive infinity, so that'll be negative infinity. So f goes to negative infinity. I hope I'm doing this right. So then the range of f is negative infinity to 0. That's what I'm thinking. Let us see. Okay, it doesn't include 1. Sorry. So we stop at, when it's exactly 1, then it's, actually, when it's very close to 1, it could be greater than 1, a little bit greater than 1, so it'll still be into negative infinity. So what's the answer to 21? Is it B? Yes, okay. So that's how I did think of it correctly. Okay. Excuse me. So once again, we recap. This absolute value x is greater than 1. Remember, we can break it up as x is less than negative 1, x is greater than 1. I focused first on this side, but we can argue that for this side, the negative number squared gives us the same value as the positive side, the corresponding positive side, okay? So we can just focus on this side, okay? As x goes to, since absolute value x has to be greater than 1, so as x goes to infinity, so as x gets bigger and bigger, that's valid, right? That's in the domain. What happens here, that's the limit as x goes to infinity of f. As this gets bigger, then we're dividing by a bigger number, so we're approaching 0. F is approaching 0. On the other hand, as we approach 1, we're dividing by a smaller and smaller number, so it's going to approach negative infinity, okay? Because as we approach 1, this it'll be infinity squared. 1 minus infinity, so that's negative infinity, okay? Hopefully that makes sense. We're already at 35 minutes. Okay, let me just finish this page, hopefully, and then we'll call it a parts, okay? We have this integral from 1 to 2, x squared minus 1 over x plus 1 dx. So how can we solve this? Well, can we cancel things out? So we can factor the top to x plus 1, x minus 1, okay? The bottom we leave alone. These we can cancel, and that's integral from 1 to 2, x minus 1 dx. Power rule, that's x squared over 2 minus x. We evaluate from 1 to 2, so that's 4 over 2 minus 2 minus half minus 1, which is this 2 minus 2 is 0. This would be negative half, so it'll be positive half. And 2 is A. Good. Okay. Derivative of this guy at x is equal to 1 is what? Okay, so again, just power rule. It'll be, this is x to the minus 3, so it'll be minus 3x to the minus 4. This is x to the minus 1, so it'll be negative, negative 1, so plus x to the minus 2. And then plus 2x, we evaluate this guy at x is equal to minus 1. So this is what? Negative 3 plus 1 minus 2. So this should be negative 4. 23b, yes. Okay. Integral from negative 2 to 2. Remember what I said earlier? When we have symmetrical limits about 0, you should pay attention. Minus 2 to 2. X to the 7th plus k, dx is equal to 16. Then k is equal to what? Okay. So integral from negative 2 to 2, x to the 7th plus k, dx is equal to 16. Okay, so how do we solve for k? Well, we could even break this. We don't have to break it up, but we could, to make our lives easier, maybe. I'm thinking, do we need to, though? Let's just first break it up into, let's just do it. Let's break this up into negative 2 to 2, x to the 7th dx, plus integral from negative 2 to 2, k dx. That's equal to 16, okay? This one, yes, we want to break it up because this is an odd function. Okay, so remember the integral from negative some value a to a of an odd function, it's 0, because in the negative x direction, the area is negative or positive. Let's say it's negative. In the positive x direction, it's the opposite sign. So that would go away. Okay, so this becomes what? If we integrate this, that's kx, evaluate from negative 2 to 2, is equal to 16. So k of 2 minus negative 2 is equal to 16, so 4. K is equal to 4. Yep. Okay, last problem, almost at 40 minutes. If f of x is e to the x, which of the following is equal to f prime of e? Is this just limit definition of the derivative? Remember what that is? Limit as h goes to 0, f of, this is f prime of e, so we can do e plus h minus f of e over h. So it'll be e to the e plus h minus, what's f of e? E to the e. 25, is it? It's this one, okay? We just had to match it. Once again, this is a limit definition of derivative. This is f prime of e. So f of e plus h, you just, when there's an x, you plug in e plus h. So e to the e plus h, we need that. That's over here and here, okay? minus f of e. What's f of e? It's e to the e. That's this one, all over h. So that's this guy. Okay, so we're at 40 minutes already. I'm going to stop here for this part. Please like the video if it was helpful, and please subscribe to the channel to look out for the next part.